Hey guys, Chris Fayte with Cheat the Game coming back at you. Today we are going to pick up part 5 of Back to Basics series, and we're going back to step number 7. We had to bypass that last time because basically step 6 and step 8 were practically the same thing, and so I just put those two together. But today we're going to be talking about code injection and the difference between code injection and AOB injection, also the similarities between the two, and also how that relates to direct byte manipulation. So we're going to be covering all three of those things in this one step, step 7. And after we get this lesson done, hopefully you'll understand basically what I want you to get out of it anyway is understanding when it's appropriate to do direct byte manipulation versus allocating memory, when it's better to go ahead and use a code injection over an AOB injection, and usually why it's better to do AOB injections over code injection. So certain situations call for different things, and we're going to discuss those. So let me go ahead and get ready, and I'll be right back with you. Alright, so we're over here at step 7. Today we're going to be talking about code injection. And let's just see here, what is the scenario for this? It says your task is to use code injection to make the button increase your health by 2 each time it is ticked. We see that we start with a value of 100. Every time we take a hit, it looks like it is subtracting just 1 from our health each time. So let's start out the very first thing that we do, and anytime you're using just standard value scanning methods, you always have to start here first. You got to find the value you're looking for and find the address that's holding that value. So and that's what we're going to do. Always got to have a base source to start out at. 93, and we see the top one change. Let's just make sure, which I'm sure it is. And you see it went down to 99. So that one definitely is our health for this scenario. Alright, well, let's just go ahead and get started by placing a debugger on it. And we're going to see what accesses the address. I like seeing everything that's going on with that value when it goes to change. You can see everything that it's going through. And right off the bat, we can see, we'll bring this up, nothing is constantly monitoring it, or it's not showing anything monitoring it. So obviously it's just going to go through something when we actually take a hit. So let's take a hit, and now we can see everything the value goes through when that value changes. Alright, so well, first of all, let's just see which opcode is writing to it. And just to reiterate, we can always tell what's going on with the value by knowing this particular thing of whatever is on the left side of the comma is being affected by whatever is on the right side of the comma. So when we see our health address on the left side of the comma, we need to take a look at the command and see what's going on with it. The command here, the operand here, is the subtraction. It's subtracting 1 from our initial value. So it's just decreasing it by 1 each time. And when we take a look at it even closer, we can tell that this is our address. We can see what's in the RSI registry in this section of memory. Remember that the registry will always hold the base address. The base address is always offset 0. And we know here that our health is 780 bytes away from that base address. Let's see here. Let's bring this up. How far is that? What is 780 in hex? That means that health address is 1,920 bytes away from the base address. So you can see it's dealing with some very big offsets in that regard. And a lot of these 64-bit games, you're going to see a lot of huge offsets sometimes. So that's not uncommon. But we also see, if you take a look down here, we also see that our address is on the left-hand side of the comma, and there's a 0 on the right. But here's another situation where we actually have to take a look at what's going on with the operand, or the instruction, or the command that's given. We see that this is a compare. It's comparing the value to 0. And later on, I'm going to do another vid in the future on what compares are really doing. It's really doing a subtraction. It's subtracting 0 away from this value, and it's comparing it to 0. But we'll talk about that later. I'm not getting into that right now. I don't want to confuse anybody, but right now we can tell that this is comparing this value to 0, and if it is 0 or if it's not 0, it's given some instructions to do something different. So let's go take a look at that just out of curiosity. And I always suggest go around and look at these things, and you can kind of piece together what may be going on here. So let's take a look at it. Here's our instruction, compare a D work, which is our health, and it's comparing it to 0. What does it need it to do? It says jump if not less. Okay, so jump if not less is the exact same thing as jump if it's greater than. Jump if it's greater than 0. So jump if not less is the same thing as jump if greater. Both do the exact same thing roughly. Okay, so since our health right now, let's take a look, is 98, it's going to continue to jump over these instructions. It's going to jump down to 2D 351, and that's down here. It's going to jump to that knot right there, and then go down this way. So it's jumping over all this right here. It's jumping over. So we can see here it's comparing it to 0. Well, what happens if it reaches 0? Then it will not jump. It's going to move this address into RCX. It's going to call this address, so it does something here. It's going to jump over to here, and that could be bringing up like a pop-up menu or something. I don't know. I don't know what it does. But we can see here it calls a different function, probably to bring up something, you failed or whatever like that. And then it looks like it starts you over again because it's moving 64 hex into our health address. But you can see over here, that's 100 per hex. It's moving 100 back into our address. Well, let's just see. Let's just see when that condition ain't met. I'm curious. I've never actually looked at it before. So let's put it on 2 for right now. So we do that. We go to hit me. We got 1 to go. So once we hit 0, the next go around, it will not meet that condition, and it will run all this mess. So let's see what happens when it does that. So we hit 0. Okay, it is 0. So let's mash hit me again. It says, you're dead. Let me revive you. I see here. So that is what that call is doing. It's jumping over here to pop up this box with this text in there. It's jumping back, and it's going to move 100 back to our health address. So this should go back to 100 when we click OK. And boom, here we go. So you can kind of piece together what's going on. It helps you kind of learn assembly a little better when you see it actually happening and seeing what the instructions are doing. So that's everything that the value goes through when it changes. When it gets to that 0, it's going to do something else, pops up the message box, then it moves 100 back into it, then we start over again. So that's interesting to know. Alright, does it change the addresses when we do that? No, it's still the same address. But what we want to do is we want to go manipulate it to your task is to use code injection to make the button increase your health by 2. So let's get over to that location, to where it's writing. We can see that the subtraction is occurring here. So let's go where that subtraction is occurring, right here. So each time it hits this instruction, it's going to subtract 1 from our health. So if we knock that out, what happens? Replace with a code that does nothing. If we do that, nothing happens to the value. It's not subtracting 1 anymore. But we can see the next button isn't appearing. We got to make it add 2. So we are going to have to manipulate that instruction even further. Let me save this, and I'll be right back with you. Alrighty, thanks for holding, guys. Now we want to decide how we want to go about manipulating it. We could change that to add and change that to 2. That should just add 2 to our health. We could do it that way. And that looks like the most logical way to do it, the easiest way to do it. So let's just do that then. So we got several ways we can go about that. Okay, there's several ways, but first let's test it. Let's just test it. Let's just change this instruction right here. This is how to test to know if you can do a direct byte manipulation. Change that to add. We're going to change that to 2. Click OK. The way you know that you can do a direct byte manipulation is that the bytes, it doesn't add or take away any bytes when you change the instruction. It's the same amount of bytes for that instruction. Then you can do a direct byte manipulation. And do a direct byte manipulation. There are some instances where you can borrow bytes and then knock out the rest to do a direct byte manipulation. However, that's very, very rare you're ever going to want to do that. Okay, very rare. So what is a direct byte manipulation versus allocating memory? Allocating memory is when you remember when we talked about how the computer is reading these bytes. These are just an interpretation of these bytes. It's just so we can read and find out what's going on here, but the computer is actually reading these bytes. The computer reads binary, converts it to bytes, and then this converts it to something we can read. But it's actually reading just these numbers in hex form. It's reading these and performing them like that. So it's basically going by these bytes. If you need to change an opcode where you're adding more instructions to it to make it perform what you need done, like comparing out or something like that, or needing more things like you have to borrow a registry and move that value into a registry, then move it into an address or whatever. If you're adding more bytes than what's originally here, always and forever, you need to allocate memory and have the program jump to that allocated memory because you're going to be using more bytes. Okay, anytime you got to place more bytes in there to make the code do what you need it to do, you're not going to be able to do a direct byte manipulation. A direct byte manipulation can only be done when the number of bytes in that instruction does not change. Okay, so we saw here all we had to do was change the command and change the number it's subtracting, but it did not change the bytes, how many bytes there are. It didn't add any bytes to it. It didn't take away any bytes from it. It used its already existing bytes. We only had to change 2 bytes, which I believe was this 86 and 02. We can change it back to sub 01 and just take a look to see which get affected. We see that changed back to AE and that went to 01, so only 2 bytes. So yes, we can do a direct byte manipulation because it's not changing the number of bytes we need to use. Alright, so we can do it that way, or we can still just go ahead and allocate memory and just have it jump there, run our code and jump back. You can do it either way. So what's the difference between the code injection and an AOB injection? Well, I'm going to show you. There's not really any difference other than how it's locating this opcode in memory, or this opcode in memory. There's no difference. It's just another way it finds this area. That's all AOBs are, and that's all code injection is. And let's just do a code injection right quick. We have to add our own enable and disable, and I'm going to get rid of this comment stuff so we can just take a good look at it. We're going to do a code injection. You can see on what address do you want to jump. This address. That address is the start of our opcode. We want you to go to this address in memory. And that's what a code injection does. There are no AO bytes that it's scanning. It's going directly, you're telling it to go directly to that address. That's the one I want manipulated. And it does. It goes directly to that address. It's actually a little quicker than an AOB scan. An AOB scan is looking for a pattern of bytes. If we did this as an AOB injection, it would look like this. AOB injection, and we just put health as the name. So now we got it looking for that address 2 different ways. Okay, we got it looking for that address 2D 72B 2 different ways. In a code injection, it's only going to the address you tell it to. And what does it do at that address? It does whatever you tell it to when you place it down here. Right here we need to jump to new mem, which is our allocated memory that we allocate. We're allocating that many hex bytes. AOB injection, what does it do? It finds a unique array. That means there's no other bytes in that section of memory that has these bytes in that particular order. Nowhere else, only there. Sometimes it's good to go ahead and put your array of bytes just to be sure about that up here in the value scanner. Place it on array of bytes. Make sure to change readable to readable and writable, and do a scan. If you have more than one address pop up here, then you're going to need to make it longer and more unique. Will it still function if there's more than one address? Possibly, because what it does, it just goes to the first pattern it finds. If this came up with like, let's try that. Let me show you. Let me just take off 2 bytes here and let's see how many. If we get other places in memory, it's not going to do it. Let's change that maybe to a wildcard or something. Well, that's a shame. I was really wanting to show you that, but that's all right. We can do it some other time. But if you've seen it yourself, if you do an array of byte scan and there's more addresses, this code will still turn on. It's just going to go to the very first address it comes to that has that particular array at it. At that byte right there. It'll always start at that very first byte. But it's looking for these pattern of bytes in that order. So if there's more than one, it's only going to come to the first one. So if the opcode that you need affecting is like the 5th address down in this, you're going to have to make it longer. It needs to only find one. Now, sometimes you get in a situation where, you know, you have 2 addresses that's just always popping up no matter how long you make it. If the address you're wanting manipulated is always popping up first, then you can probably get around it that way and just go ahead and use the AOB injection. As long as it's the first one it's getting to every time. But, you know, that's just my way of doing things. But anyway, that's the only difference between a code injection and an AOB injection, is how it finds that location. How it's finding this opcode right here. Just 2 different ways of finding the same place in memory. That's all it's doing. Now, code injection is great because it gets there quicker. The problem with code injection, if anything ever updates, and you know what happens in an update, right? That means that they're adding to the program. They're doing new scripts. They're putting more scripts in there, or they could be taking some out, or both. That means all these bytes are going to shift. And that's when that comes into play, to know that each byte has its own unique address. That means that the start of this byte from then on is going to be at maybe a different address. So that address is no longer going to be valid in the update. If all the bytes shifted over, if more bytes got added into the program or got taken away from the program, these bytes are going to shift to make up for that space or for those new bytes. So the address will change. Okay? So code injection only works for that particular update of the game. If you update it, you're going to have to do it all over again. That's why we say try to find an array of bytes. Usually array of bytes will work in an update. Sometimes you have to go play around with them a little bit more. Some bytes might have changed a little bit and you have to go wildcard, and I'll show how to do that which in another vid, and I'll put that up at the upper right hand corner, how to work with AOBs in an update. But a lot of times it can still find that place because the patterns will about 80% of the time stay the same. Okay, sometimes we have to make it a little more unique, but with a code injection, you're just going to have to redo it from scratch. If you don't have an array of bytes it can find, you're going to have to redo the whole thing from scratch. AOB, all you got to do is just see if you can find it with a new array of bytes, but it's a lot easier to find in an update than having to do it all over again. Especially if you're in some complicated cheat where you had to do a lot of back tracing or something like that, you could be in some trouble. And having to redo all that over again from scratch can be a pain. But anyway, that's the only difference. Is code injection is going directly to the address. AOB scan is looking for a unique pattern of bytes to start at, which is that address. Okay, that's the only difference. But this is wanting us to deal with code injection, and we can do it 2 ways. We can have it jump to allocated memory and have it run our code, and then it will jump back to here and continue where it left off. We're going to do that first, which basically all we do is add to. Assign that to the current cheat table. Alright, so allocating memory, that means we told it at that address right here, place a jump, which we've already learned, a jump to allocated memory, which we're calling new mem. We need 5 bytes for that jump. We need the command plus the 4 byte address of the allocated memory. Okay, so let's see right here. If you take a look, we have 1, 2, 3, 4, 5. We need those many bytes to jump to allocated memory, and you see we have 2 bytes left over. Those need to be knocked out. We've already discussed that knopping out bytes is saying, hey, computer, those bytes still exist. Do not get rid of them. We still need them later. We're just not using them right now. Okay? So that's why we had to place the 2 nops here. So jump to allocated memory and 2 nops. And when we turn that code on, that's exactly what it's going to put there. Jump, and it's going to put the address of where new mem's been allocated at. It's going to place those 2 nops. Let's go ahead and do that, and you're going to see that. Okay? There's where we allocated our memory. Here's our jump to allocated memory and our 2 nops. So let's go over to our allocated memory, and here is our cheat. So when the game gets to that location, or the tutorial gets to that location, the program, it's going to jump to allocated memory, come to here, it's going to read that add to our health address, and then it's going to jump back. We're going to follow that and pick up where it left off. It jumps back to here. Exactly what we told it to do. So if I'm at hit me, take a look. It's adding to, our next button appears, we passed the scenario. But how do I know, how can I do it differently? We already learned that we can already do a direct byte manipulation. We are not affecting how many bytes there are here. We're not adding any bytes, we're not taking away any bytes, we're just changing a couple of bytes. We can also do it that way. What were those 2 bytes again? Add, and then O2. It's the second one and the last one. We need to change that AE to 86 and that O1 to O2. That 86 means add to the computer. That O2 is hex O2. We can do it that way. Let's do that. Let's change it back to what it originally was. Sub 1. So it changes it back to what it originally was, and we can actually change it in the very script we just did. We just tell it we don't want it to allocate memory no more, which means we don't need labels, we don't need all this mess, we just need the address we're telling it to go to. We don't need to deallocate mem, we just need the address we're telling it to go to. That's it. So what are we going to tell it here? Well, we can do it 2 ways. We can manipulate the bytes, or we can just tell it directly. Since it doesn't add to or take away bytes, we can just copy and paste this, change that to add, and O2. It's not adding any bytes, it's not taking away any bytes, it's just changing already existing bytes. Okay? So let's go ahead, put it on here. Now let's take a look at the instruction. What happens? It won't be a jump to new mem anymore. It's going to be what we told it to put there. Take a look. Add to. Or we could do it by the bytes itself. Remember, the bytes are what the computer is actually reading. It's just translating those bytes for us to this so we can read it. But it's actually reading that. This is just an interpretation. If I went to just an off random byte in memory, say if I went to the very next byte over, which is 86, these things would be all askewed and messed up. That's when you scroll up or down, then and you see different instructions, say, hey, what's going on here? Well, you started in the middle of a byte somewhere that was already in the middle of an opcode, and it messed up the interpretation. So let's just do it bytes instead. Define byte, or DB. That really means, it means declare byte, declare bytes, and these are the bytes we want declared right here. And what was it? 86, and then O2. So if we put that, what's going to happen? Take a look. The same exact thing. Why? Because it's reading these bytes. Computer's reading these bytes. It's not reading this. We're the only ones reading this. It's reading this. So either way, it's doing the exact same thing. So you saw we can allocate memory. It does the exact same thing. We can do it several different ways to achieve the same results. And we can even change how it puts subtract back. We can take that out and just put the bytes instead of what they originally were. and it will still restore it back to this. So if I turn it on, add 2, and it changes it back to subtract 01. So once you understand how the computer is reading these things, it's reading bytes, you don't take away or add to these bytes, then you can just directly manipulate those bytes without having to jump to allocated memory, or you can just go ahead and jump to allocated memory. It does not matter. And when we write a script, we want it to work whenever we come back to it, so we don't have to look up that value anymore. So that's what we're going to do. We're going to bring it up anew, and we can see now it's no longer reading that tutorial until we hook it back to there. There we go. We can see it come back up at the very same address. This is a new game now, and we're going to bypass all our steps to get to step 7. All the next button appears, change the value, next button appears, change pointer, wait to 3 seconds, next button appears, and now we're on step 7. So right here, we're going to put in our bypass step 7, which basically just does the scenario. I didn't really bypass it, it's just doing what we told it to do. We turn it on. Go take a look, make sure it changes that to an add and that to a 2. And remember, we left it at the direct byte manipulation, just changing the bytes. Bring that back up. Alright, we turn it on and take a look. Now we changed it to add 2. What does it do? It adds 2, and the next button appears, and we can continue on, bypass number 8 and change pointer. Let's see if that works. Remember changing that one. Yeah, there we go. And the very next lesson will be on step number 9. I want to thank you guys so much for coming out. If you can all do me a favor, please drop a like on the videos and let me know that this is helping you out some. I really appreciate it. I want to thank you all for coming out and supporting Cheat the Game. Also to my partners. Without these guys here, these are my Patreon pals, Cheat the Game would not be existing right now, nor would I be making these videos. So it's all thanks to them, and I really appreciate it. Thank you all so much, and we'd love to have you over there. They have exclusive content that they have access to, and it comes out every month, and it's only for them, and we'd love to have you aboard on that as well. Please, you can also join us over at our Facebook channel or Discord, and we also have a website. We're still trying to get it up and going and everything. I just haven't had time to deal with it right now, but I'm still working on it at the moment. So hopefully we can get that in full force here pretty soon. But come join us. All the links are in the description, and we'd love to have you. If you have any questions, you can come post them there, and just come ask your questions. We're happy to help. Alright guys, I'm out of here. You all take care. You keep on hacking. Most importantly, please enjoy yourself. That's really what it's all about. You cheat the game, fellas, because Blue doesn't mind cheating you. I'll see you on the next one.